Okay, last page of 4.1 notes. Okay, so this is page 5 of section 4.1. Okay, so last example, we're gonna run the gamut. So we'll do the whole process here on this problem. It says the data below describes the monthly income of 7 people and the number of times they eat out each month. Okay, so someone making $500 a month, they ate out 8 times. These must be students. How can you survive on $500 a month or $400 a month? Yeah, these must be students. These must be students still living at home with their parents or something. But anyway, so this is their monthly income, and then this is the number of times they eat out each month. So it says use StatCrunch to draw a scatter plot, find the correlation coefficient, and then see what type of correlation exists, if any. Okay, so I'm going to go to StatCrunch and enter this data. So again, pull up StatCrunch, follow along with me, make sure that you can do this, right? I think the best recipe for success is to kind of try to pretend like this is, that you're actually in class. Okay. You got income, meals. Again, make sure that you're getting these in the right order so that everything matches up the way it's supposed to. And then I'm going to double check real quick. So 508. Okay, looks good. Okay, so to draw a scatter plot, again, we go to graph and then scatter plot. You tell StatCrunch which one is your x variable, which one is your y variable, and then you hit compute. Hard to tell. Hard to tell if there's a linear correlation here, especially with this guy down here, right? This is kind of an outlier, I think. Anyway, could be a negative linear correlation, possibly. To be sure, we would compute the linear correlation coefficient, which is what we're asked to do in part B anyway. So let's do that. All right, so for the linear correlation coefficient, we go to Stat, Summary Stats, Correlation. We want to see if income and meals are correlated. So we select those two variables and then hit compute. Okay. So we get a correlation coefficient of negative 0.229 approximately. That's not very good. That's not a strong correlation at all. So I'm going to come back to the notes now and write down some of these observations. Okay, so part A, we did this in StatCrunch. Part B, so part A was done in StatCrunch. Part B, we got R was approximately negative 0.229. And then to answer the question in part C, what type of linear correlation is there between? Well, first of all, we'd have to look up the critical value to see what number we had to beat. Okay, so the critical value in this case is going to correspond to 7, n equals 7, because there are 1, 2, 3, 4, 5, 6, 7. Our sample size is 7 individuals. So looking at n equals 7, the critical value that we had to beat was 0.754. So for n equals 7, the critical value is, what did I say? 0.754. 0.754. So we can say something like, since the absolute value of R is less than the critical value, right? again, this is absolute value of r, it's less than our critical value, right? So since our correlation coefficient is less than our critical value, there is no linear correlation. Okay, no linear correlation. And that's that. Okay, that's the answer to the question. One thing that we've talked about before when we were talking about designed experiments versus observational studies is we said correlation does not necessarily imply causality, right? So we'll kind of reiterate that again here. If the data is from an observational study, then correlation does not imply causality. And I think I gave this example when we went over that section, but it's kind of an interesting thing. Both teenage birth rates and homicide rates have been declining since 1993. So there's a strong correlation between those two variables, right? There's a strong correlation between teenage birth rates and homicide rates, but neither one of them really causes the other to happen, right? So there's a strong correlation, but that does not imply a causal relationship. It doesn't imply that one of them is causing the other, right? And that's kind of the problem with observational studies, okay? Not that they're completely useless. What an observational study does is it kind of tells you, okay, here are two things that are correlated. Now let's try to see if there's a causal relationship between them. And to determine if there's a causal relationship between them, then that's when you would perform a designed experiment. Okay, so if the data comes from a designed experiment, then correlation could imply causality if all of the other variables, all of your lurking variables are controlled, right? So if all other variables are controlled and you change an explanatory variable and the response variable also changes, well then you know it was the change in the explanatory variable that caused that response, right? So that's that, right? We could get really controversial here really pretty quickly, but there are all kinds of observational studies that are performed all the time, and then people jump to conclusions about, so this thing is causing the other, but that doesn't necessarily follow, okay? It doesn't mean, if there's a correlation, that doesn't necessarily mean that there's a causal relationship between things, okay? And that does it for 4.1. Here are your homework assignments. You can use StatCrunch on any of these. I think some of the problems might say, do this thing by hand. Don't do anything by hand. Just use StatCrunch for all of it, okay? So that's it.